Dear students, welcome to the chapter Chemical Bonding and its theory session number 8 in physical chemistry. In our last theory session, we did our discussion on valence shell electron pair repulsion theory or the VACPR theory. This theory session number 8 will deal with the molecular orbital theory, in short known as the MO theory. Now, molecular orbital theory was put forward by Hung and Mulliken in the year 1932. So these were the scientists who put forward the molecular orbital theory. To understand the physical meaning of this molecular orbital theory, we have to remember the wave function psi. Now, what does the wave function psi characterize? The wave function psi, this corresponds to the amplitude of the wave process characterizing the state of an electron in an atom. So this is actually characterizing the state of an electron in an atom. Amplitudes of molecular waves or molecular electron wave are formed by the summation of amplitude of interacting atomic electron waves. So we can see that a molecular electron waves are formed due to the addition of the atomic electron waves. So this is by a simple summation of the different atomic electron waves that we get a molecular electron wave. Now suppose the interacting electron orbitals of associating atoms are characterized by the wave function, suppose psi1, psi2, psi3, etc. Then we can represent the wave function psi of the molecular orbital. So if this is the wave function of the molecular orbital, this is equal to psi1, C1 psi1 plus C2 psi2 plus C3 psi3, where we can say that C1, C2, C3 are all numerical coefficients. Now for an 1s orbital we can say that, so for 1s orbital C1 is equal to C2 is equal to C. The coefficient C does not affect the form of the required molecular wave function but only changes the magnitude. Therefore we can say that psi is equal to psi1 plus psi2 when the signs of both of the wave functions are the same. Now when the signs of the wave function of any interacting 1s orbital are different, then we can say that the wave function of the molecular orbital is psi is equal to psi 1 minus psi 2. So we can say that this is when the sign are different, and the first case is when the sign are the same. Now we come to the concept of a bonding molecular orbital. So this is the concept about a bonding molecular orbital designated by psi b. The first thing, that if there is a constructive combination of two atomic orbitals, or in this case we can say that if there is a constructive combination of two different atomic electron waves, this will help in keeping the two particular atoms together. Therefore we can say that psi b is equal to psi 1 plus psi 2. So this is the case when the atoms will stay together or there can be a formation of bond. Now probability of finding electron is given by psi b square is equal to psi 1 plus psi 2 whole square, which is equal to psi 1 square plus psi 2 square plus 2 psi 1 psi 2. So this is the probability of finding electron out there. Now we can draw the formation of a bonding molecular orbital from atomic 1s orbital. How? Let us have a look at this following diagram. If this is the axis, so there are two wave functions on the same axis. We can name this as psi 1 and psi 2. So this is the internuclear distance, that is the r. Now if there is a constructive combination or a constructive overlap, the picture will be like this. So this is psi bonding. So this is the picture if there is a constructive overlap between two atomic orbitals leading to the formation of a molecular orbital of high electron density. So now we will also consider the effect of formation of an antibonding molecular orbital. So our next course of study is the antibonding molecular orbitals. Now since the bonding molecular orbitals were formed due to the constructive overlap or the constructive combination of two atomic orbitals, antibonding molecular orbital are formed when there is a destructive, or we can say out of phase combination of two atomic orbitals. Now this out of phase combination of two atomic orbitals will lead to the decreased or zero electron density between the two nuclei. So this will result in the decrease of electron density between the two nuclei of a resulting molecule. This kind of MO is known as the anti-bonding MO. Now let us have a pictorial representation of the so-called formation of an antibonding molecular orbital from 1s atomic orbitals. So if I am looking about a pictorial representation, it will be as such. You have the axis out here. So here is the wave function psi1. This is psi2. And because of the outer phase combination, I can draw the diagram as follows. This is psi A. This is the distance r. And we can say that psi A is equal to psi1 minus psi2. The negative sign representing this outer phase or the destructive combination of the two atomic orbitals, or the destructive combination of two atomic electron waves. Now how can we represent the probability of finding an electron in a antibonding MO? So the probability is given by psi A square is equal to psi1 minus psi2 whole square, which is equal to psi1 square plus psi2 square minus 2 psi1 psi2. So from the above equation we can see that for an antibonding molecular orbital, the electron cloud is less by 2 psi1 psi2 then the sum of the electron densities of the two isolated atomic orbitals are psi1 square plus psi2 square. So this is the sum of electron densities of the two isolated atomic orbitals.